All right, in this video, we're going to talk about calculating margin of error. A survey of 2,300 people reported that 28% of respondents, meaning people who filled out the survey, eat sushi. To the nearest tenth of a percent, that's one decimal place, what's the margin of error for the survey? So the formula for margin of error, which you have to memorize, is it's going to be 1 over the square root of the sample size. N represents how many people took the survey. So the margin of error here is going to be 1 over the square root of 2,300. So you put it in your calculator, boom, you get this. However, I don't want the margin of error as a decimal like this. I want it as a percent. I'll go ahead and write this down though. So 0.0208. Do I need to round that up? Okay. I'm trying to cut it off here, have my 4 decimal places for now. But this 8, am I going to leave it in 8 or do I need to round it up to a 9? I need to round that up to a 9 because if the next number, whoa, why did that happen? I meant to do that. Look, so now we can see clearly. If the next number is 5 or higher, you need to round up. So I'm going to go 0.0209. I have no idea why that happened. So 0.0209. In this unit, rounding is going to be really, really important, so get used to it. But we won't leave it like this. How will I write this as a percent? 2.09%. Now they said, this time I specifically said the nearest tenth of a percent. So really I should say 2.1%. Just do what it says. Round, if it says, if you're not sure whether tenth of a percent means 1 decimal place or 2, I would tell you that on quiz day. If you say, Mr. Bird, how many decimals? 1 decimal place. But once I say that, give me just 1 decimal place. Okay. So that's the margin of error. Now give me an interval that is likely to contain the exact percent of the population that eats sushi. So in the survey, 28% of the people said they eat sushi. Margin of error means that, okay, if I were to somehow ask every single member of the entire population, the real percentage of people who eat sushi might be a little higher or lower than that. And that's what the margin of error tells you. So it might be a little bit higher or lower, meaning plus or minus 2.1%. So by adding and subtracting to what the survey result said, that'll give me a range, a window. And the exact value, if somehow I could have asked the entire population, the real answer should be in there somewhere. So we are doing interval notation though. So the order matters. It always needs to be least to greatest. So that means subtract first. So what's 28 minus 2.1? Give me that number first. 25.9. So the lower bound is 25.9%. And if I add 30.1%. Okay? So that means, and this is the answer to part C, the exact value, the exact percentage of people who eat sushi is likely to be between 25.9% and 30.1%. So that's what I mean when I say interpret this interval in the context of the problem. I'm asking you to give me a sentence describing what this means. Make sure you mention what the problem is about. This problem is about people eating sushi. So your sentence should say something about that, for sure. Any questions about number 10? Okay, I'm remembering last year, a problem like number 11, A, was the most commonly missed problem on the quiz last year. So I hope everyone is paying attention to this. Actually, like, the problem the reason why people were missing it is because this is really from like Algebra 1 middle school. This is not a new Algebra 2 concept, and so people blew it, okay? Okay, the survey reported that 930 students out of 1,500 high school students had an iPhone, okay? Find P, the proportion of students who had an iPhone. Express your answer as a percent. So basically, look, on the previous problem, I just gave you the proportion. All right? On the last problem, I just said, oh, 28% of the people said they eat sushi. This time, I didn't give you the percent. I'm leaving you to calculate that percent yourself. So you just have to remember how to calculate a percent. So if 930 students out of 1,500 had an iPhone, how do I make that into the percent of people that had an iPhone? Yeah, you just do 930 divided by 1,500, all right? And then you're going to multiply by 100, move the decimal point twice. So this is what you should be doing for this problem. So it's 930 divided by what again? 1,500. Okay, so what is that as a percent? That's 62%. All right, so that's the proportion that I'm talking about. Okay, 62%. And then now we'll use that number the same way we used the 28% on the previous problem. So what's the margin of error for the survey? Well, the margin of error is 1 over the square root of the sample size. Which one of these numbers? Yeah, this is another mistake that students made last year. I had some students doing the square root of 930. I had other students doing the square root of 1,500. Which one of those is the sample size? It's the 930, okay? Did 1,500 people take this? Actually, hold on. It's a 1,500, okay? Because the sample size is how many people took the survey, right? 930 people said they had an iPhone, but 1,500 people took the survey. And that's your sample size, how many people took the survey. So it's going to be the 1,500, not the 930 that goes right there. Okay? Give me the decimal first, if you do you have 258? Okay, which translates into, and it says nearest tenth, so, all right, so that's 2 point, and we'll round it, like you said, 2.6%. Any questions on that? Do you understand why I picked the 1,500, not the 930? Okay. All right, now, give an interval that's likely to contain the exact percent of students that have an iPhone. So now we're going to take that 62% plus or minus our 2.6%. Okay, so what's the lower bound? And what's the upper bound? Okay, have I lost anybody? Quiz is tomorrow. Don't be shy. Don't be shy. All right? And when I say interpret this interval in the context of a problem, I just want a sentence. Let's see. The exact percentage of students who have an iPhone. Wait, 1 second. 1 sec. Because we're recording this and it's like, you know what I mean? The exact percentage of students who have an iPhone is likely to be between 59.4% and 64.6%. Okay, any questions on that? Okay, just a couple more left. Yeah, let's just wrap this up. So, all right, number 12. The design of a study is unbiased if, all right, I'm going to pause the video, but I want you to show me on your fingers which one of these letters you think it is. We'll use 1 finger for A, 2 for B, 3 for C, etc. So the answer should be C. Unbiased means you don't want your survey questions affecting the outcome. So if the design of your study doesn't affect the outcomes, that's what would make it unbiased. Okay, now number 13, the sample size required to achieve a margin of error of blah. Okay, so they're giving us the margin of error this time. So remember the formula goes like this. Margin of error is equal to 1 over the square root of the sample size. So if the margin of error is 3.4%, am I going to put 3.4 right here? All right, because that's the margin of error. So is that what I do? Should I go on from here? I have to write it as a decimal. All right, 3.4 is a percent. I can't use that within the formula. So I need to convert this. Instead of writing 3.4, which is a common mistake that I saw last year, don't let it happen to you, I'm going to write 0.034 and then go. All right? So now I'm going to solve this for n. Now, there's a shortcut that I recommend, Christian, which is that when you have a number equal to a fraction like this, you can always swap these two values. There's a longer way that I showed you yesterday, but this is really the shortcut that I like to use. If I just swap these two things, immediately I have this. I have the square root of n is equal to 1 over 0.034. That's a valid move. Now, how do I make that square root sign go away? You square both sides. Technically, it's not square root because I'd be square rooting square root. What you mean is square both sides, like this. All right? Now put all of that in your calculator just like it is. All right, so 0.034. So 1 over 0.034 squared, just like that. Boom. So we get this. I see 5.05. Now, how would I really write this in my final answer, guys? Yeah, I would definitely just write 865 because n represents, the number of people surveyed or the number of objects measured. This can't be a decimal. So round up or down to the nearest whole number anytime you are finding the sample size. Say again? Yeah, you're just going to have to pick the closest thing. Okay? It's not going to be exact. Because we did round. You know what I mean? So this is the sample size that would be required to get you exactly 3.4%. So which one of these numbers is going to get us the closest? Yeah, 872 is the best thing you have. So that would give you, and maybe if I plugged in 872, maybe it would give me a number that rounded to 3.4. I'm not sure. But that's definitely the closest, so just pick that one. Okay, last question. For some reason, this question was commonly missed also last year. I'm going to pause the video after I read the question to give you a chance to think, but I really would like everyone to participate on this question because half of you are about to get it wrong, and that's a good thing because the quiz is not today. So if you get it wrong now, we can work it out, and then tomorrow we'll all get it right. So I'd rather you get it wrong today so you can get it right tomorrow. Let's see. Mr. Huff wants to know the opinions of parents of RHS students about a proposed new schedule. He obtains a list of all RHS parents and then randomly selects 300 to which to send a questionnaire. Awkwardly worded. Only 100 are returned. What is the population and what is the sample of this situation? Okay, so the population, that's who you care about, who you're interested in. Right at the beginning it says, Mr. Huff wants to know the opinions of the parents of RHS students. So right there, that eliminates some of the answers. Okay, so that eliminates A and B and C. Okay, it even eliminates F. Right, did he send a questionnaire to every single RHS parent? No. So the population wouldn't be the parents who received a questionnaire. The population is everyone you care to know about. And he wants to know the opinions of RHS, the parents of RHS students, all of them. He's using a sample to predict how all of the parents would feel. So it's either D or E immediately because of just from that. Now as far as the sample, can he use as evidence the ones that were thrown in the trash can? No. The only evidence he has are the ones that were actually returned. Right? You can't judge from the ones that didn't get answered. Those won't be part of the sample. So it had to be the parents who responded. The parents who responded. That's why the answer was E.